Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-8 Extra Practice Number 2 solutions on polynomial and rational inequalities. To solve this polynomial inequality, we're going to start by getting critical values, graphing those on a number line, and then doing some sign analysis around those. So for critical values, I'm looking for things that zero out each of these factors, since it's already in factored form. So for this first factor here, x plus 4, negative 4 will be a root for that one. And then we have negative 2. And then for this last one, that's going to be negative 3. All right, let's go through and put these on a number line now. Now, since I have an equals in my inequality, that means these are all going to be solid dots when I put them on this number line. So we've got negative 4, that's the furthest one to the left. And then negative 3 is actually the next one, if we move to the right here. And then finally, negative 2. So picking some numbers around those, to the left of negative 4, I can use negative 5. Plugging that in, I've got negative 5 plus 4, which is negative. Negative 5 plus 2 and plus 3 is also going to be negatives. So that's 3 negatives. An odd number of negatives gives me an odd overall result when I multiply those. Now I have to pick a number between negative 4 and negative 3. Let me choose negative 3.5. So negative 3.5 plus 4, that's going to come out positive. And then negative 3.5 plus 2 and plus 3, those are both coming out negative. Even number of negatives is going to give us a positive result. Now a number between negative 3 and negative 2, I'll use negative 2.5. Negative 2.5 plus 4, that's going to be positive. Plus 2 is going to be a negative. And then negative 2.5 plus 3 is a positive. So that's a single negative for that middle factor, giving us a negative overall result. And then finally, a number to the right of negative 2. Let me use 0. So 0 plus 4 plus 2 plus 3, that's positive in all three cases. So positive overall result for that. Now my inequality is saying greater than 0. That means I want all the positive intervals. So I've got this second interval right here that I'm going to shade, and also this interval over here on the right. And now writing all that in interval notation, I have an interval of negative 4, comma negative 3, both with brackets because I have solid dots on those. Union, and then I got bracket negative 2, comma infinity, and infinity always gets a parentheses. For this inequality, I'm trying to graph it and also write the interval that's the solution. So to do that, I need to find critical values and do some sign analysis around those. For critical values, since it's a polynomial, I'm just looking for the roots, the numbers that zero this out. So to figure that out, I need to first factor this. Now this one's a little bit tricky to factor, but you might notice that we have 4 terms. So we can at least explore the idea of factoring by grouping. So let me look at my first 2 terms. I can take out a common factor of x squared from those. That leaves me with an x plus 5. From my next 2 terms, my greatest common factor is negative 16. Taking that out, I have an x and another plus 5. Since I have the same thing in both of those parentheses, I can take out x plus 5 as a common factor, and then the leftovers are going to be the x squared and the negative 16. Now the x squared minus 16 can get factored a little bit further as well. That's really going to be x plus 4 and x minus 4. So my final factorization, I've got the x plus 5 still, x plus 4 and x minus 4. And now going through and zeroing out each of those factors, I get roots of negative 5, negative 4, and for this last one, positive 4. Let me go ahead and put those on a number line. Since I have an equals in my inequality, that means I'm going to have a solid dot on each of these roots because they're all going to be part of the solution. So I have negative 5 on the far left, and then I've got negative 4 after that, and positive 4 is my rightmost boundary marker there. All right, let me pick a number in each of these 4 intervals and do some sign analysis. So to the left of negative 5, I can use negative 6. Plugging that into the fully factored version here, I've got negative 6 plus 5 is a negative, plus 4 is a negative, minus 4, negative 6 minus 4 is another negative. That's 3 negatives. Odd number of negatives gives me a negative result. And now a number between negative 5 and negative 4. Let me use negative 4.5. So negative 4.5 plus 5 gives me a positive. Adding that with a 4 gives me a negative and another negative if I subtract 4 from negative 4.5. That's 2 negatives, giving me a positive result overall. And now this is the easiest one. Between negative 4 and 4, I'm going to use 0. 0 plus 5 and 0 plus 4 are both positive. 0 minus 4 is a negative. Just one negative gives us a negative result. And then finally, after 4, I'll use 5. 5 plus 5, 5 plus 4, 5 minus 4. Those all come out positive, giving me a positive overall result. My inequality says less than 0. So that means I need negative intervals. So looking at the ones I labeled as negatives, that's the leftmost interval and this third interval here. And writing that in interval notation for the left one, I've got negative infinity, comma, negative 5. Parentheses on the infinity, bracket on the negative 5, because negative 5 is a solid dot for that endpoint. And now I need a union and brackets negative 4, comma, positive 4. For this rational inequality, to solve this one, we need to first get critical values, which are going to be roots and also discontinuities. Since this is already factored, we can pick both of these out pretty quickly. The discontinuities are going to zero out my denominator. So looking at each of these factors, I have a discontinuity for this first one at x equals 6. And now we have one as well for the 3 here, 3 minus 3 giving us 0 in the denominator. For the roots, that's anything that makes just the numerator 0. So really there's only one factor up here, so negative 1 plus 1 would zero that out. And let me put all these now on a number line and do some sign analysis. So the furthest one to the left is the negative 1. Since that's a root, and since we have an equals under the inequality, that means that I'm going to have a solid dot at negative 1. Moving to the right, we have 3. That's the next number. Discontinuities are automatically open dots. So we've got 3 open dot and an open dot at 6 as well. Now doing some sign analysis around each of these, a number to the left of negative 1, I'm going to go with negative 2. So plugging that in and counting up the negatives, negative 2 plus 1 is a negative. Minus 6 gives us another negative. Negative 2 minus 3 is a third negative. 3 negatives, odd number of negatives, negative overall result. Now between negative 1 and 3, I can use 0. 0 plus 1 is positive. Minus 6 gives us a negative, also negative if I do 0 minus 3. That's an even number of negatives, 2 to be precise, so that's a positive overall result. And now between 3 and 6, I'll use 4. 4 plus 1, positive. Minus 6 is a negative. 4 minus 3 is a positive. Just one negative gives us a negative result. And after 6, I can use 7. So that's going to be a positive, positive, and another positive for all 3 of those. So positive overall. Now my inequality is saying less than 0, so that means I want the negatives. That's this far left interval here, and also this third interval. And writing that in interval notation for the far left, I've got negative infinity, comma, negative 1, parentheses on the infinity, bracket on the negative 1 because of the solid dot, and then union 3, comma 6, both of those parentheses because those are both open dots. To graph and solve this inequality, let me start by getting some critical values. Since this is already all factored, I can just pick those out from the factors that I have. I'll start with the discontinuities. Those are the x values that are going to give us 0 in the denominator. So taking a look at this x plus 6, if I use negative 6 for x, that would zero that out. So that's my one discontinuity is negative 6. For the roots, that's going to make only the numerator 0 and zero out the whole fraction. So up here we've got negative 4 for this first factor and then negative 5 for the other one. Let me put those on a number line now. The furthest one to the left is going to be negative 6. Since that's a discontinuity, it is automatically an open dot. And now my roots, since we have no equals in the inequality, these are actually also going to be open dots. So the next one in line is this negative 5, followed by negative 4, all open dots. All right, let me choose a number from each interval and test those out. I'll go with negative 7 for the leftmost interval. Now, one thing that'll save me a little time here, this squared factor in the denominator, that has to come out positive no matter what I plug in. So I can just ignore it and just focus on the x plus 4 and the x plus 5 when I'm seeing how many negatives I have. So plugging negative 7 in up here, Negative 7 plus 4 is negative, plus 5 is also negative. Two negatives gives me a positive. Next, between negative 6 and negative 5, I can use negative 5.5. That's going to give us a negative and a negative if we plug it in up there. So again, that's going to be a positive, two negatives. Between negative 5 and negative 4, I'll use negative 4.5. Negative 4.5 plus 4 gives us a negative. Plus 5, though, is going to come out positive. So that's negative since we just have one negative overall. And bigger than negative 4, let me use 0. So that's going to be 0 plus 4 and 0 plus 5, both positive, so that comes out positive. Now the inequality was for less than 0, so that means I want all the negatives. We've just got one interval with those. That's this negative 5 to negative 4 interval. So after shading that one in, I'll just write that interval out as negative 5 comma negative 4, both parentheses because we have open dots on either end. For this inequality, if I want to get the graph and the solution to this, I'm first going to need to find critical values and do sign analysis around those. So critical values, basically things that zero out either the numerator or the denominator. I'm going to have to factor first before I can see what those are. In the numerator, this is an a squared minus b squared kind of situation, so I can just use square roots and do a plus minus kind of parentheses. So I'll have x plus 7 and x minus 7. And then down below I need things that multiply to give me 32 and add up to negative 12. So negative 4 and negative 8 will fit the bill on that one. So I can write x minus 4, x minus 8. I'll list the discontinuities first. Those are things that zero out the denominator. So that's going to be 4 and 8 for those two factors. And my roots that zero out only the numerator, that'll be a negative 7 for that first one, followed by a positive 7. Now let me put all this on a number line and do my sign analysis. So the furthest one to the left is this negative 7, and because I have no equals on my inequality, both of my roots are going to be open dots. So I'll have a negative 7 open dot there. After that, the next one is going to be 4. Discontinuities are automatically open dots. So we have a 4. 7 is the next number after that, followed by 8. Testing a number in each of these intervals now. For negative 7 to the left of that, I'm going to use something like negative 8. You could use negative a million if you wanted to. Plugging that into all of my factors in my factored form. Negative 8 plus 7 is a negative. Negative 8 minus 7 is negative. Minus 4 is negative. Negative 8 minus another 8 is still very negative. That's 4 negatives. Even number of negatives gives me a positive overall. Next, between negative 7 and 4, I'm going to use 0. So we've got a positive. Next one is a negative, and then we have negatives for the bottom two factors. So that's a total of 3 negatives. Odd number of negatives gives me a negative. Between 4 and 7, let me use 5. 5 plus 7 is positive. Minus 7 is negative. Minus 4 is positive. 5 minus 8 is negative. These two negatives gives me a positive overall. Now between 7 and 8, I'm going to use 7.5 or 7.5. So 7.5 plus 7, that's positive. Minus 7 is still positive. Minus 4, still positive. The only negative we get is 7.5 minus 8. One negative gives us a negative overall. Finally, number bigger than 8, let me use 9. 9 plus or minus all of these things is going to come out positive. So that's a positive overall result there. Now for the inequality, we had greater than 0 as the inequality. That means positives. So I have this left region here, the middle, and I'll shade the rightmost region as well. I labeled all those with positives. Writing out this in interval notation, I'm going to have all parentheses because I'm working with infinities and open dots everywhere, so no brackets needed. My first interval goes from negative infinity to negative 7, union 4, comma 7, union 8, comma infinity.